For my capstone project, I'm gonna send the Arduino up into the air in my homemade RC plane to collect measurements from this environmental BME280 sensor and record them in the Arduino's onboard 1 kilobyte of EEPROM memory. I also made a parallel connector which allows an FPV transmitter to stream live video from the camera in flight. Now I hooked up these 17 gazillion cables inside the airplane to connect to the environmental sensor, which will be giving me humidity, altitude, and temperature data once every second for 5 minutes and 30 seconds. Now I just need to connect a jumper wire between pin 12 and the ground for the Arduino to start collecting the data. Timer for 5 minutes so I know how long to fly. The Arduino flies aboard this airplane. I landed the plane after about 5 minutes. Let's check the measurements. I don't think the Arduino was taking the measurements because I don't think the jumper wire was properly hooked up or something. So let's try that again.
Okay.
I took out the FPV video transmitter to have more space and less wire jumbles. Okay, now it's blinking. That means it's collecting the measurements. Can you set a timer for 5 minutes? Now let's cut the throttle and glide the plane down. Let's do one last loop. It looks like it's still blinking. That means it's still collecting data, which means it was a success. I told the Arduino to output the collected flight data from the EEPROM to the serial monitor, and then I copied that into an Excel spreadsheet. I have some data coming in. Now I'm flying FPV, seeing a live stream of the video that the plane is seeing. Here's an overview of the code I was using for my Arduino. I start by importing all the necessary libraries and setting up the sea level pressure for my BME280 sensor. Then I set up all the necessary libraries and open the serial monitor, which will allow me to output data from the flight. Then I set up pin 13 as my onboard LED indicator and pins 12 and 11, which will be used to trigger certain functions of the Arduino. Here is an alert system which will flash the built-in indicator in case the BME280 sensor couldn't be detected. So if the pin 12 is connected to ground with a jumper wire, it waits 15 seconds and then starts collecting data, a total of 330 times in this for loop. It collects Celsius, the altitude, and the moisture, and it does this 2 times per each measurement, takes the average, and writes them in byte format to the onboard EEPROM memory. Here's the part that writes it to the EEPROM memory. And then this is what I was using to test if the measurements were coming in correctly. So this is the if statement that happens if pin 11 is connected to ground. And that's what makes the Arduino output the collected data from EEPROM to the serial monitor. So first it prints what it's going to be outputting, and it goes through the loop 330 times and outputs every single measurement, decoding them from the byte format, and prints them. And that's my code. This is the temperature graph from the flight. It stays mostly at around 6 Celsius, which proves the temperature variations at these low altitudes are negligible. I most likely caused this spike at the beginning by handling the sensor with my warm hands. This humidity graph doesn't show correlation with my altitude graph, so this trend is probably unrelated to altitude, but we can still tell that this was a rather humid day overall. Let's view the onboard footage. Sorry for the annoying shake effect, which I caused by accidentally turning on this camera's video stabilization feature. Here's the altitude graph for this flight.